Abbe's refractometer. A. To find the refractive index of the given liquid sample. Apparatus: Abbe's refractometer, cotton cloth, light source, and samples. Theory: refraction is the change in the direction of a wave passing from one medium to another caused by its change in speed. Refraction occurs when light passes from one medium to another medium with a different index of refraction. According to the properties of an optical medium, some portion of light entering the interface at an incident angle alpha is reflected back to the first medium, while the rest propagates into the other medium at an angle of refraction beta. The angle of incidence, reflection, and refraction are defined as angles between the particular ray and interface normal. The refractive angle is determined by Snell's law, n1 sin alpha is equal to n2 sin beta, where n1 is a refractive index of medium 1 and n2 is a refractive index of medium 2. Also, sin I by sin r is equal to n is equal to velocity of light in first medium divided by velocity of light in second medium, where I and r are the angle of incidence and angle of refraction respectively for medium 1, which is vacuum. The above ratio is known as the refractive index of medium 2, which is always greater than unity. Refractive index depends on the density of the measured sample, which is affected by its temperature. Refractive index increases as temperature decreases, and the variation can be defined by equation. N of 20 is equal to N of t plus t minus 20 into 0.00045, where N of t is a refractive index of the liquid sample at T temperature, N of 20 is a refractive index of liquid sample at 20 degrees Celsius, and 0.00045 is a multiplying factor of Abbe's refractometer. Refractive index also depends on wavelength of light used, because the speed of light waves depend on their wavelength. Light of different wavelengths will bend at different angles even if the angle of incidence are same. Variation of refractive index at a different wavelength can be calculated as lambda 1 divided by lambda 2 is equal to n2 divided by n1, where lambda 1 and lambda 2 are the wavelengths of first and second light source, and n1 and n2 are the corresponding refractive indices of the liquid. Using Closures-Moussot relation, we can calculate polarizability of the given liquid, where Na is Avogadro number, ρ is density, m is molecular mass, alpha p is a polarizability, and absolute zero is permittivity in free space. Procedure: turn on the light source. Open the double prism of the refractometer. Clean both glass surfaces and close the double prism. Use a pipette to fill the space between the two prisms with the given liquid. Turn the refractometer scale knob to get a clear interface between the illuminated and dark regions. Use a micrometric screw for additional refinement of the scale until the clear interface appears. Read out the integer value from the rough scale and the decimal number from the refined scale. Read the index of refraction using the telescope scale. Open the double prism and dry out glass surfaces. Repeat the experiment with the different liquids. Applications: to calibrate refractometers and other optical instruments, to identify particles and particulates from air or water,